Now I'd like to talk about fields and properties. These are what we use to handle data inside our classes. Fields are the easiest thing to understand. A field is just a variable that belongs to your class. This field can be of any type, int, string, whatever. But it can also be a user-defined type like another class. And we're going to get into this later. But when you're building more complicated applications, oftentimes you'll need more than just a primitive type of int and string, so a field can also be a class. This field has scope to the entire class. When you hear a developer talk about scope, that means where can this thing be used? And when we define a field in a class, it means it can be used anywhere in the class. If you recall, when we did our stopwatch application, we created a private datetime field that kept track of the start time. And in the start method, we set it to the current date time. And in the stop method, we used it to calculate how much time had been elapsed. That single variable was available in both methods. This is not like a parameter of a method. A parameter is a variable whose scope is only inside that method. Most often, we use these fields to store information that we want to keep private in our class. Why would we want to keep data private? Because we want to protect it from people meddling with it in ways that we don't approve of. We can mark fields as public. It's permissible. If you mark a field as public, then anyone who has the class can set it to whatever they want directly, just like any other variable. This is not common, however. If we have public data, we usually use properties, which we're going to get into in just a moment. First, let's take a look at a fictional bank account, though. This bank account has a private field, private decimal underscore account balance. The underscore, I'm a little bit old school. Some of the younger developers don't do this that much anymore. I prefer to use the underscore on private fields because that used to be shorthand syntax to let another developer know that the field they're working with is private. I picked that up when I was young. I still do it today. But notice that we have a public void method called withdraw. And it takes a parameter that's the amount of money we want to withdraw from a bank account. Now, those of us that have bank accounts know that if you only have a $50 balance, you can't withdraw $100. If the account balance field was public, that would mean that any programmer out there who had access to our bank account class could just set the account balance to whatever they wanted. In this case, if they want to withdraw money from the account, they now have to use my method. And in the method, the first thing I do is check to see if the amount is greater than the balance. And if it is, I'm going to write out a little message and not withdraw the money. If the account balance is more than the amount, though, the else statement, I can go ahead and subtract the amount from their balance, and that's fine. Notice in our program, main, we instantiate a bank account. If I try to use the dot syntax to get to the account balance field, I'm going to get an error because account balance is private. Only methods inside the bank account class are allowed to change that value directly. So it is protected from meddling in other programs. Next, we have properties. Properties represent items of data in a class or class instance. They look on the outside very much like a field, but on the inside, they have a name, a type, and they can be assigned to and read from using the get and set accessors. So that's the main difference between a property and a field. Properties have something called get and set. and I'm going to show you what this is used for. Properties are actually methods. They don't look like it, but underneath they are. In other languages, most notably Java, there's no such thing as a property. If you want to protect your data just like a property does in Java, you have to write your own get and set methods. This is sort of what a Java class would look like. It would have a private string underscore instructor name. I'm modeling a classroom, a course. That underscore instructor name is called the backing field. That's where the data actually lives. And anybody who wants to read the instructor name must call the get instructor name method, and it's going to return the data back to them. Anyone who wants to assign the instructor name has to call the set instructor name method and pass in a string value that we'll use for assignment. The next code sample shows how we do this in .NET with properties. In C#, we can still have the backing field, but we can shorthand those two methods by putting them as get and set. Get still returns the value of the private backing field, and set still sets the backing field to the value passed in. Notice that this time the value keyword is blue instead of black. In the above example, set instructor name, value is a variable, and it's one that we defined. We could have named that whatever we wanted. In a property, like the bottom example, the set accessor has a keyword called value, and that is set to whatever another programmer tries to assign the instructor name to. So if we say course.instructor name equals Joe, the blue value keyword will have the value of Joe inside it. That is called a contextual keyword in C#, because value will only turn blue and be a keyword inside a set method. We can omit the backing field and the code blocks for get and set. If we do this, it's called an auto property. So here's a code sample right here. Public string, so accessor, everybody can see it. Type, it's a string. Name, instructor name. And then a code block with just get semicolon set semicolon. This code and the code above it do the same thing. They are totally equivalent. It's just that the bottom syntax is preferred because it's shorter. The only reason we use a backing field for properties in C# is if we want to control access to the data or sometimes do a calculated field. I'm going to show you examples of this. But one thing I want to tell you before we move on is the top example, where it has two methods and a backing field. When we compile our code, if we have the bottom example in our code and we compile it, it's going to generate out two methods and a backing field. So that top example is what you get from the bottom example. It's just that the bottom example is much shorter to write and much easier to read. Unlike fields, properties give us control over the reading and writing of the data in our class. So here's an example. Our developers can write code with get and set accessors. We have an elementary school student here. That student has a private variable that represents their grade level. The get just returns the grade level. That means anybody can read the grade level from this class. However, in the set method, in my school, grade levels in elementary school had to be between grade 1 and grade 5. So in my set, I've said if the value passed in is less than 0 or greater than 5, then write out that the grade level is out of range, and then return an empty return. That just exits from a method. So here I've said that if anybody tries to set a grade level outside of 1 and 5, don't do it. Don't allow that. However, after the if statement there, if it gets to that line, then I know that the grade level value passed in is between 1 and 5. It's acceptable. So then I will save it to the backing field. Validating data is one powerful use of property syntax. It keeps us from having our class data get corrupted or set to values that don't make sense. If I didn't write this code this way, somebody could come along and set the grade level to minus 762, and that would be nonsensical. Properties can also be used as calculated fields. So sometimes we have data in this class that's dependent on other fields or properties. We refer to these as dependent or calculated fields. In this case, we're going to not use the set accessor of the property. This makes the property read only. So check this out. We have a rectangle class. It has two properties on it, width and height. They have get and set accessors with no logic in them. That means somebody can set the width and height of the rectangle to whatever they want. Then I have a third property called area. And those of us that took math in school, we know that the area is the width times the height of the rectangle. If I had both get and set properties for the area, then whenever somebody changed the width or the height, I would have to make sure in that code that we also updated the area. That would be a little bit more work than I would want to do. So in this case, I got rid of the set property. Nobody can write to the area value. However, everybody can read from the area. And whenever they read from the area, it's going to do the calculation. So if somebody has changed the width or the height in between reads, it's always going to be up to date. I recommend that you type this code into Visual Studio and give it a try to watch it, because it's very cool. So in our fictional program, we have a main method. We're going to instantiate a new rectangle object. We're going to set the height equal to 10. We're going to set the width equal to 5. Then we're going to print out the rectangle's area. In that console write line statement, when it says a rectangle object dot area, it's going to return width times height, which is going to be 50. On the next line, I tried to directly set the area to 20. That got a red underline in Visual Studio because there is no set accessor, so you're not allowed to set it equal to anything. You can only read it, like I did up in console write line. It is a read-only variable. Note that if we do want to have a set method, but we don't want other people to mess with it, we can put the word private in front of set. And that would mean that anyone could read it using the get accessor, but private set would mean that only the rectangle class can set the value. It's not very common. I just want you to know it's possible. So in conclusion, use private fields for data you want to hide or protect. Use properties for data you want to expose. And if a property depends on other values or is a calculated field, then don't use a set accessor on the property. In our code samples coming up, I'm going to start using properties and fields quite a bit, so you're going to have some time to get comfortable with this.